Welcome to Science versus Scientism. I'm your host, Nathan Oakley, and if you are new to this channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show and a link in the info box once the video has rendered. Joining me this evening is John, otherwise known as Quantum Eraser. How are you doing, John? Good to have you here.
Doing fine, Nathan. Thanks for having me.
It's an absolute pleasure. You're going to hopefully take us through a few logical fallacies which we have definitely fallen victim to during the debate process about Flat Earth. So where do we begin?
Well, it's not only logical fallacies. A big problem is what is and what is not science. So we're going to get into that here in a few minutes, and then we'll finish it up with some flat Earth proofs.
Excellent. Let me know when you want to present and I'll stick your screen up.
Yeah, go ahead and let me know when it's up.
Yep, you're up. You're presented. Everyone can see you.
All right, well, let's just dive in then. So let's start off with the pseudoscience pretender clowns. These guys right here. Paleontology, anthropology, archaeology, geology, evolutionary biology. Yeah, I'm still laughing. Theoretical physics, non-experimental. Astrophysics, astronomy, and cosmology. Crocheting is more scientific than these clowns combined. This is very important right here. Make sure that you understand this, because any claims coming from these guys, and we're going to focus on these three for our genre, but any claims coming from these guys aren't scientific. The first six pretenders can't get to the first step of the scientific method, so they're gone. You know, they can't observe a phenomenon without a time machine. And the final three masqueraders, the ones in our genre, astrophysics, astronomy, and cosmology, they can't formulate scientific hypotheses because they lack independent variables. They can't isolate and test and validate their dependent variables or their predictions. The true sciences are quantum mechanics, genetics, chemistry, biochemistry, and biology. These are the true guys right here. Now, there's a caveat with this. They don't get out of jail free card. Each claim from any of these must be accompanied by experiment. Must be. If not, if no experiment, then it's codswallop baloney for them also. The scientific method. This and this alone. You either follow the scientific method or you don't. If you don't follow the scientific method, then it's not science, period, end of story. So bare bones, it has 4 steps. From the University of Rochester Physics Department. Of observation and description of phenomena. Basically, what they do is mirror my highlighted steps up here. Now, I'm not saying that let's review or analyze data or report results is not important. They're just admin and logistic functions. So it must follow the 4 steps. The scientific method distinguishes science from other forms of explanation because of its requirement for systematic experimentation. If you don't have experiment, you don't have science. From introduction to theory and application of molecular and quantum mechanics, the final arbiter of truth in science is experiment. From the chair of physics at Yale, Professor Shanker, the only way things change in physics is experiment. Everything is based on experiment. That's the only way we change our mind. From Richard Feynman, if it doesn't agree with experiment, it's wrong. And that simple statement is the key to science. From Max Planck, experiment is the only means of knowledge at our disposal. Everything else is poetry and imagination. The scientific method requires that a hypothesis be ruled out or modified if its predictions are clearly and repeatedly incompatible with experimental tests. Further, no matter how elegant a theory is, its predictions must agree with experimental results if we are to believe that it is a valid description of nature. In physics, as in every experimental science, experiment is supreme, and experimental verification of hypothetical predictions is absolutely necessary. Now, does everyone understand the importance of experiment? You got to have it. So what's an experiment? From Penn State University, there should be 3 categories of variables in every experiment: the dependent, the independent, and the control. That's an experiment. So what is it? Well, it's a hypothesis test. That's all. What's a scientific hypothesis? Now, I bolded some terms here. They're going to be repeating refrains with many citations here from Colorado State, California State, the University of North Carolina, and Penn State. I want you to keep an eye out there for them. A scientific hypothesis, like I said, is your experiment statement. It expresses a testable proposed cause and effect relationship. The scientific method is hypothesis driven. One makes an educated guess to explain what? A cause and effect relationship. A scientific hypothesis is a special kind of a prediction. We're going to get to that here in a little bit, that forecast how the independent variable will affect the dependent variable. The scientist applies his or her present knowledge to predict the effect of the independent variable on the dependent variable. See the repeating refrains here. They're all saying the same thing. The prediction is a statement of the expected results of the experiment based on the hypothesis. The prediction is often an if and then statement. Again, a scientific hypothesis based on cause and effect. Formalized hypotheses contain 2 variables, independent and dependent. This alone is science. You have your independent variable, that's your cause, plus your dependent variable, which is the effect, equals prediction of cause and effect. This alone is science, right here. Nothing more, nothing less. In an experiment, the independent variable is a variable that is varied or manipulated by the researcher, and the dependent variable is the response that is measured. From Penn State, independent variable, it's varied during the experiment. It's what the investigator thinks will affect the dependent variable. From Colorado State, independent variable, it's varied and manipulated. You see the repeating refrain here. Cause and effect is the sine qua non. That's the quintessential tenet of the scientific method. It's the entire spine of science. An independent variable is the presumed cause, whereas the dependent variable is the presumed effect. Or the IV is the antecedent and the dependent variable is the consequent. It's just that simple. Now, question: is the flat Earth or a sphere, or any other shape for that matter, a cause and effect question, a how-I question, or is it a what is question? Well, it's a what is question. Can what is questions be adjudicated via the scientific method? What we just went over? No, they can't. This isn't science. No what is questions can be allowed in the scientific method. So what we got here by the truckloads are Elmer Fudd's pretending to be Richard Feynman's. This is painfully obvious. Another term that's used flippantly throughout this genre: predictions. A scientific prediction is the result of interactions between independent and dependent variables. You got to have a hypothesis to have a scientific prediction. From Colorado State, scientific hypothesis, a special kind of prediction that forecasts how the independent variable will affect the dependent variable. So question: can you have a scientific prediction without a viable and independent and dependent variable? No. There's quite a large chasm between Gene Dixon, Edgar Casey, Nostradamus, carnival tent, and cyclic repeat dictions, and scientific predictions. So, from the Elmer Fudd Reference Library, Wiki. In everyday speech, theory can imply that something is an unsubstantiated and speculative guess, the opposite of its meaning in science. These different usages are comparable to the opposing usages of prediction in science versus everyday speech. So we're used to this one, the typical parrot, the claim, we can predict eclipses. Well, I always retort with, well, what's your scientific hypothesis and independent variable? Then the name calling ensues. Well, you got to have the scientific hypothesis and independent variable for a scientific prediction. Predicting eclipses, this is tantamount to watching a clock for 300 years. Then at midnight of the first day of the 301st year, the diviner predicts that in the next 4 hours, the hour hand will land on 3. Wow, that's amazing. He must be a seer. Here's the next prediction. After watching Super Bowls every year for 40 years, I predict that next year in late January or February that a Super Bowl will be played in a stadium with the over-under not exceeding 80. Nostradamus, move over. Right? That's ridiculous. Watching recurring patterns and regularities, then pontificating, is not a scientific prediction, folks. From John Steele, eclipse prediction in Mesopotamia. Look at this. Lunar and solar eclipses predicted by the Babylonians in 800 BC. He even uses the term prediction. Is this a scientific prediction? No. The predictions generally include the expected time of the eclipse, apparently calculated quite precisely. I'm pretty sure that the Babylonians or the Mayans didn't have the heliocentric spinning ball model. I'm pretty sure about that. These are not predictions. They're just watching recurring patterns and regularities. That's it. This is critically important right here. The ultimate goal of every single scientific inquiry is to falsify or reject the null hypothesis. The null hypothesis, aka the zero difference hypothesis from California State. To do a hypothesis test, you will actually have two hypotheses, the null and the alternative, which are stated in such a way that they are mutually exclusive. Excuse me, you can't have both hypotheses be true. The null hypothesis is a conclusion that is considered the default. That is, you will accept this hypothesis if you fail to find sufficient support for the alternative. So let's do a couple. Now, don't forget, the scientific method has got to follow it, especially that first step. It's a killer. So, example 1, observe a phenomenon. Sailors complain of severe joint pain, bleeding gums, rashes, etc. after long sea journeys. Now, there could be a number of possible causes here, but for brevity and for the concept here, that's all we're going for. We boil it down to fruit and vegetable intake. So, the alternative hypothesis. If vitamin C intake is crucial to collagen integrity in humans, then eliminating vitamin C intake in humans will cause scurvy. The null. If vitamin C intake is crucial to collagen integrity in humans, then eliminating vitamin C intake in humans will not cause scurvy. These are valid scientific hypotheses in the null hypothesis, and it's just this simple. The alternative is will, the null is not. That's simple. The dependent variable here is scurvy. Good to go. Independent variable. Can we vary and manipulate the intake of vitamin C? Yeah. This is a valid scientific inquiry. No problems. This can be testable. Oh, by the way, if your independent variable here, vitamin C, or the lack of, has no effect, then you try another independent variable. There's this whole slew of them that can be tried here, especially with nutrition. Bear in mind, if you try a variable with no effect, your inquiry or experiment is not a failure. Why? Because you just eliminated a possible cause. You're good to go. So, example 2, observe a phenomenon. Healthy type 1 diabetics suffer from diabetic ketoacidosis, apparently from the absence of adequate insulin. So the alternative, given otherwise healthy type 1 diabetes patients, the lack of insulin will lead to diabetic ketoacidosis. Real simple. This is a valid scientific hypothesis. That's simple, folks. Conversely, the null, given otherwise healthy type 1 diabetes patients, the lack of insulin will not lead to diabetic ketoacidosis. This is pretty simple. I think you guys got this, right? Real easy. These make sense. The dependent variable, your prediction or the effect, is diabetic ketoacidosis. Independent variable, again, you can vary and manipulate this. This is good to go. This is a valid scientific inquiry and valid hypotheses. No worries, too easy. Example 3. People observe ships going over the horizon. Okay, what's the alternative hypothesis? Well, if the Earth is a sphere, then ships traveling away from you will eventually disappear from view hull first. The null hypothesis, if the Earth is a sphere, then ships traveling away from you will not eventually disappear from view hull first. Say what? This doesn't even make sense, right? It makes no sense. Null is a non sequitur fallacy from the Black Lagoon, mainly because the variable here is not a viable independent variable. To reject or falsify the null, you must be able to physically manipulate the independent variable. Can anyone physically manipulate the Earth? I don't think so. This entire charade is an invalid scientific inquiry, a non sequitur fallacy, and pseudoscience. Also, the alternative hypothesis up here is an affirmative consequent formological fallacy. This guy right here. This is a train wreck. Every single spinning ball proof is constructed exactly like this. You all know it. You all hear them every day. They're constructed exactly like that, folks. They're train wrecks. Dismiss them. Here's another term that's flippantly thrown about, for the past 3 or 4 years. I must hear this term model over 50 times a day. Well, what is it? From Physics About, a model is used for situations when it is known that the hypothesis has a limitation on its validity. Does that make any sense? No. Allow me to translate that. It's pseudoscience. There's no such animal as a scientific hypothesis with limited validity. It's tantamount to a woman being a little pregnant. Real scientific hypotheses are either confirmed or invalidated by experiment. Period. End of story. Scientific hypotheses don't exist in perpetuity or wait for more data. You get data by conducting experiments. A model is conjured when the alleged hypothesis is untestable. That means there never was an actual scientific hypothesis to begin with. It's a fiasco, folks. Don't let them do it. Maps, that is projections, aren't scientific models. Mathematics isn't scientific models. And a model doesn't make scientific predictions. Why? Because if it did, it would be a valid scientific hypothesis instead of a hypothesis with limitations on its validity. Make sense? Another term and concept that is used flippantly, math. Mathematics isn't science or physics, much like a tape measure isn't carpentry. One of the main reasons is they're two different words. From Professor Balakrishnan from ITT Madras. That's the whole point about physics. It's not mathematics, right? Pretty cut and dry right here. Maths don't prove reality. For example, 1 apple minus 6 apples, negative 5 apples, right? Well, 1 minus 6 is negative 5. That's a mathematical proof, right? Well, show me negative 5 apples. Best wishes. And I like this one. Give me the equation for germ theory. Not going to happen. Math is immaterial and abstract, rigidly domain specific, and at best merely describes. It explains exactly squat, nada, niente. Conversely, actual scientists are in the business of explaining phenomena by validating or invalidating cause and effect relationships between independent and dependent variables. We already talked about that. Can you show one case in all history where mathematics caused any phenomena? Can you show the laws of motion causing a billiard ball to roll across a table? Right? This is a preposterous statement. The next canard. Now, any explanations, any moron could give you an explanation, right? Watch, a friend discovers large burned scorch marks on his garage walls, right? He gets out there, he measures the diameter, circumference, he does all kind of chemical testing. He then concludes that invisible fire-breathing dragons exist, right? Well, what's the problem? It matches the observations. The key is, can you scientifically validate your explanation via experiment? So I just ask them these questions, right? Which they can't answer. If you can't scientifically validate your explanation, then all you have is a just so story. It's a fairy tale. Rest assured, any member of the spinning ball congregation will be more than happy to provide you a just so story, right? Parroted, one each. Then what happens? What's the next thing that happens after they give their explanation? We all know it. You're immediately challenged to disprove it, right? Well, just so story fairy tales, aka arguments from ignorance fallacies, can't be disproved. Why? Well, it's the acme of foolishness to even consider, much less attempt to disprove complete arguments from ignorance fallacies. Do you find it scientific or logical to imagine things, then have other people attempt to disprove your imaginings before you give evidence of your imaginings? This is preposterous. This appeal is tantamount to claiming that dark matter is created by invisible three-toed gnomes throwing pixie dust in a black hole behind the Crab Nebula, then requesting others disprove it, or therefore your claim is true. Ridiculous. Scientifically validate your claims first, then I'll pummel them. Here's a familiar one. You know, I haven't heard this one in a while though. I mean, this was running rampant for about, I don't know, a year and a half. I just haven't heard it in a while. They may have got the memo, right? And everyone's heard this. Stars spin in opposite directions in the northern versus southern latitudes. And what's their explanation? Well, we live on a spinning ball. Don't matches the observations, right? Here we go again with those invisible fire-breathing dragons. Conclusions from mere observations, that is, looking at something, are solely drawn from inference. Those are educated guesses at best. Conclusions from experiments are solely drawn from practical demonstrations of cause and effect relationships. So scientifically validate, please. Go ahead. Do it. Then I get the usual wiki says, you're dishonest satellites. You know the drill. By the way, this is mind-numbing juvenile short bus parlor trick. Watch this. What direction, north, south, east, or west, are stars spinning in the northern hemiplane? Answer, east to west. Conversely, what direction, north, south, east to west, are stars spinning in the southern hemiplane? Answer, well, they're spinning from east to west too. According to NASA, the sun, the moon, the planets, and the stars all rise in the east and set in the west. Right? We all know this. The tomfoolery description of clockwise and anti-clockwise, or opposing directions, is relative to your position. Like, if you're standing in between two carousels and both are spinning from east to west, and you look at the northern carousel, you face north and look at the northern carousel. It's spinning from your right to left. That's counterclockwise. You then turn around, you do an about face south, and then look at the southern carousel. It's spinning from your left to right or clockwise, right? But that doesn't make any difference. You then look at Dopey the Clown and announce these carousels are spinning in opposite directions. Yeah, then everyone at the carnival, including all the second graders and above, roll their eyes and they start laughing and throw their cotton candy at you. Why? Because there's no difference here. You're just changing your reference frame. That's it. You're just turning around. Then Dopey the Clown hires you on the spot. Your new name is Doofus the Clown. All right, this is one of my pet peeves right here, buddy. I've been hearing this ever since the beginning, and I'll tell you what, I'm glad I have hair left because I've been pulling it out over this nonsensical buffoonery. Science says. Let me tell you something, folks. Science doesn't say anything. It isn't an entity or a result. We just went over it above. It's the scientific method. It's a method. It's a concept. That's all it is. Methods don't say, jump, run, swim, point to, or do the hokey pokey. To do such things takes sentience, prescience, and intelligence to be alive. Additionally, to say something takes vocal cords, tongue, lips, lungs, and typing skills. Science isn't alive or have any biological anatomy. Therefore, it's a reification fallacy. Please, if you're listening out there, would you stop doing this? Stop saying science says. It doesn't say anything. And we get to the two canards that are the savior of the spinning ball religion, right? Refraction, aka atmospheric or terrestrial refraction. This is very important right here. This is something that no one ever says. Let's take a look at begging the question fallacies. Let's let this marinate for a minute. So a begging the question fallacy happens when you take the premises, or one of your premises, include the claim that the conclusion is true, or directly or indirectly assume that the conclusion is true. Let that marinate for a minute. So what's the overall conclusion from the spinning ball congregation, right? The earth is a sphere, correct? What do they use as one of their premises to prove that conclusion? Well, atmospheric or terrestrial refraction. This, folks, is a stone cold textbook begging the question fallacy. Watch. Does light refract? Yeah. Is that the same that can be accounted for by terrestrial refraction? No. Key word is terrestrial. You see, terrestrial refraction already assumes a sphere. But that's what they're trying to prove. From San Diego State, the atmosphere is also curved as it follows the shape of the Earth. In the calculations below, we'll adopt a rough value of 6,400 kilometers as the radius of curvature to make the calculation simple. Well, they're assuming the very thing they're attempting to prove, right? Curvature. That's a textbook begging the question fallacy, circular banjo do-si-do. You're going around in circles with this, folks. Don't let them do it. What must they do? Now they can use it, but what must they do before appealing to terrestrial refraction? Well, they have to scientifically validate the radius of the Earth. If they're going to use it in the calculations, well, they have to scientifically validate it first, or we're just going to be chasing our tails. Then I ask these questions again. Scientifically validate. Well, you'd have better chances resurrecting Alexander the Great's horse than coherently answering those questions. All right, another one of our favorites, right? Gravity. This explains everything. This is the savior. Now, any moron knows that if you drop an anvil from elevation, that it's going to fall to the ground. Spouting off a word that describes the action, gravity, or ducal slopegerts, or I can make up any name, doesn't validate that it's the cause. Okay? Whenever somebody states gravity, they're immediately invoking a cause, whether they know it or like it or not. It's either number one, mass attracting mass. That's Newtonian gravity. I call it Cavendish. Let's just call it Cavendish Newtonian gravity, and I'm gonna show you why here in a minute. Or two, space-time, the Einsteinian version of it. The Cavendish or Newtonian gravity is a force Whereas the Einsteinian gravity is not a force. So if somebody tells you, well, what's the difference, or there is no difference, well, there is a big difference. It's right here. This is a big problem. They're not the same. They're not even in the same geometry. Newtonian or Cavendish gravity is in Euclidean 3 space, whereas Einsteinian gravity is pseudo-Riemannian 4 space. They are mutually exclusive, folks. So one or the other. It can't be both. So let's take a look at what Newton proposed, right? This is his equation. Remember, mathematics isn't science. This is just an equation. It's just a description, right? Newton proposed that. Well, Cavendish, 100 years later, proposed this. Are these the same equations? No. So, Cavendish gravity. That's why I call it that. Newton himself wasn't exactly married to the idea. Check this out. In a letter to Dr. Richard Bentley on February 25th, 1692, Isaac Newton says, "'Tis inconceivable that inanimate brute matter should, without mediation of something else which is not material, operate upon and affect other matter without mutual contact. That gravity should be innate, inherent, and essential to matter, so that one body can act upon another at a distance through a vacuum." They knew it was a vacuum back then. I wonder how they knew that. "Without mediation of anything else by and through which their action or force may be conveyed from one to another is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into." So, if you believe in Newtonian or Cavendish gravity, what is Sir Isaac telling you, or where should you be taken? Right? That's a straitjacket statement. And you should be institutionalized. That's more or less what he's telling you here. So let's end this Newtonian Cavendish gravity buffoonery quick. The scientific community, whoever or wherever they are, doesn't follow Newtonian or Cavendish gravity. This is a real gaggle, folks. From George Musser, Einstein created his general theory of relativity, which provides our modern understanding of gravity, with the express purpose of expunging non-locality from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the one in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction. It's over right there. They don't even follow it. So why am I here in Newtonian gravity? I don't know. Einstein's turn. So relativity, special relativity and general relativity, these are not theories, by the way. They're not scientific theories. That's another discussion. Via different mechanisms, speed versus gravity, can dilate, bend, or warp time. Are you kidding me? Let's go with the primary school falsification. Time is a conceptual relationship between two motions. Specifically, it's based on an alleged single rotation of the Earth on its axis in respect to the sun a day. It's a concept. It's not physical. It's without chemical formula, structure, dimensionality, orthogonality, direction, or location. You can't put some in a jar and paint it red. I mean, come on now, let's reason together. Can you dilate, bend, or warp non-physical concepts? Is it your contention that if you have poison ivy on the brain, you could scratch it by thinking of sandpaper? If you could do this, folks, you need to find the carnival. Change your vocation. Freedom is a concept, too. Can you bend that? Moreover, that which you are using to measure isn't the thing that you're measuring. Example, a football field is 100 yards long, but a football field isn't yardsticks. If I bend a yardstick, does the football field bend also? No, of course not. So if something affects, say, a cesium atomic clock, or any modern clock for that matter, does that then ipso facto mean the Earth's alleged rotation in relation to the sun is affected? These two mytho-mathematical fairy tales, special relativity and general relativity, were falsified 30 seconds after their respective publications by third graders at recess. In total, each are massive reification fallacies on steroids. Now, if you want to see the official debunking of Newtonian mechanics and Einsteinian's relativity, head on over to Cathexis's channel. We have a presentation on gravity.
Can you remember which number it is?
Period.
Can you remember which number that is, John?
Say again?
Which number, science versus scientism? I think there's 13 in total.
Yeah, that's a good question. I can't remember which number it is. If you get, it's episode. It's one of the episodes in that in the list of 14.
Fair enough.
Oh, this is quite interesting right here. Listen to this, folks. So, Martin Rees, astronomer royal, esteemed British cosmologist and astrophysicist. Let's see what he has to say. What causes gravity and mass? These questions still baffle all of us. What? What on earth? According to Professor Rees, does mass attracting mass cause gravity? Nope. There goes Cavendish and Newtonian gravity. According to Professor Rees right here, does space-time cause gravity? Nope. What on earth, folks? Why are you bringing this stuff up? Can somebody, anybody, please tell me why I continually have to put up with this? This gravity nonsense, why? The card-carrying spinning ballers response, we all know this one. We've all been challenged with this. I've personally been challenged with this greater than 1,000, 1,500 times at least. Well, if gravity doesn't exist, what's your explanation? Right? Well, number one, there isn't an if about it because it doesn't exist. Number two, I don't need to provide a replacement explanation to pummel your explanation. And number three, what we call gravity, or I can call it Ducal Slopergerts, doesn't matter. It's law-like. That is, it's a natural law. The cause of each natural law isn't a scientific question. It's a moronic inquiry. Watch. The second law of thermodynamics, the laws of entropy. Heat flows from hot to cold always, right? Well, what's the cause of that? We don't know, and we'll never know. It just does, and it's a does and it is. That's why they're called the laws of thermodynamics and not the theories of thermodynamics. Because scientific laws are descriptions. They describe the what's and the is's of natural laws. And by the way, folks, you see this scientific here in the scientific laws? This scientific here is a misnomer. There's no science in here. None of the laws even get within 500 meters of the scientific method. When somebody says scientific laws or physical laws, all they're saying is their description of natural laws. No science in it whatsoever, as opposed to scientific theories. They go through the scientific method. Their explanation of the hows and the whys. And what else? The key, remember? They identify the cause, like germ theory. That's the whole point of the scientific method. Remember, cause and effect. So, okay. Let's round this off with the flat Earth proofs. Now, remember that I said neither flat or sphere Earth is scientific evidence. It cannot enter the scientific method. So the sword cuts both ways. However, these are logical consistency proofs. Now, they're not as sexy as scientific evidence, but I'll tell you what, they got teeth. So the Bolivian salt flats, this is quite beautiful, folks, right? If ever, make up a bucket list, I'm going to tell you what, this is going to be high on the list. So according to the heliocentric sun-worshipping spinning ball religion, every point along a tangent in every direction from your feet drops. That is, vertical drop away from you at 8 inches per mile squared. You all know this. From Borsa et al., Topography of the Salar. The Salar del Uyuni, I know I'm screwing that up, in the Bolivian Andes is the largest salt flat on Earth, exhibiting less than 1 meter of vertical relief over an area of 9,000 square kilometers. Folks, this is a geometrical flat plane. You can have a myriad of topographical features on a sphere: mountains, ridges, saddles, spurs, depressions. You know what you can't have? You can't have a geometrical flat plane. It's a contradiction. And this one is over 9,000 square kilometers. Therefore, how can you stage 5 cling with a kung fu death grip to this fairy tale religion that has one of its foundational tenets, vertical drop, and yet at the same time have a flat plane with less than 1 meter vertical drop? You can't have it. Over the north and south limit, let's take a look at this. Let's open this up. They got a picture of the Salar here, figure 6. It gives the distance of going north and south in the Salar and how far it is. Let's roll on down here. So figure 6, where are you? There she is. Okay. As you can see here, the distance between A alpha and alpha prime is 100 kilometers, right? It's over. So 100 kilometers. Put that in your calculator. What are you going to get? So for the spinning ball, 100 kilometers or 62 miles, the vertical drop is 781 meters. That's what you should have, right? Slam dunk. The Bolivian salt flats, 100 kilometers. How much vertical drop? It's less than 1 meter. Where's the 780 meters? Where'd that go? I don't know where it is. Somebody needs to show it, or they're not on a spinning ball. Next, the Sea Sparrow, the evolved Sea Sparrow missile. One of my favorites. The Block 1. Take a look at this picture, folks. It's a pretty good picture. I want you to notice a couple things. Number one, you see this contraption right here? This is the target illumination radar. Number one. And number two, in my calculations below, I used 80 feet above sea level. Now, I don't know, but that doesn't look like 80 feet to me. 30 feet at best, or 40 feet. It's not 80. So I'm giving them the benefit of the doubt there. So the general characteristics of the ESS and Block 1. Primary function, surface to air, and what? Surface to surface radar guided missile. The range is more than 35 miles. It's much more than this, but that's all they give you. The rest is classified, but it's at least that. The missile receives a reflected signal from a target that's being illuminated with an RF pencil beam that's transmitted by the fire control radar. That fire control radar is what I just identified above, the target illumination radar right here. It's on a standoff platform. Such systems require that the platform maintain line of sight. Line of sight. I'm sure all you folks got it now. It needs line of sight to engage those targets. This is slam dunk. So the target is illuminated with a 2-degree RF pencil beam, which has to be maintained, painted on the target until detonation. At a more than generous 80 feet elevation above sea level, which it's not, give you the benefit of the doubt, even then it's a train wreck. This is the target illumination radar height. The target should be hidden behind 385 feet of curvature.
Sorry to interrupt, John.
Folks, RF,
can you go through that whole sentence again? Because that's one of my favourite flat Earth proofs.
With this one right here?
Yeah, the target is illuminate. You've got it.
Okay. Yep. The target it must be illuminated by a 2-degree RF pencil beam, which has to be maintained or painted on the target until detonation. At a more than generous 80 feet above sea level, that's the target illumination or radar height. I just showed you that above. The target should be hidden behind 385 feet of curvature. It's over right here. So what they have to do, they have to explain how you can have line of sight 35 miles away on a spinning ball and show how a 2-degree RF pencil beam can penetrate 385 feet or 117 meters of target hidden night through a wall of water 24 miles in length. Ain't gonna happen. Just doesn't do it.
Yeah, we know this from
So
the
the sea,
debates. This is just like I say, it's just one of my favourite things. It's worth just pausing on it for a moment, because we know from the Isle of Man that as soon as you get beyond a certain distance, it's all refraction.
yeah, I was going to say that. So they're not firing at refracted images. Let me assure you. So, in summary, with this, the sea sparrow's max effective range is greater than 35 miles. Surface targets are engaged by the sea sparrow. To engage the target, it must be illuminated by the RF, the 2-degree RF pencil beam. That's therefore it must have line of sight. The target illumination radar must be on the same ship as the missile. And I'm going to get to that here in a second below. Hold on. Because that's one of the main comebacks to this. We're going to pummel it here in a second. So conclusion, either the Sea Sparrow missile, the Block 1 exists, or the spinning ball religion exists. Both can't be true. The end. So, like I said, the main comebacks to this argument is they say, well, you can have people on different ships or different, places. The ship can be 35 miles away, but the target illumination radar could be 3 miles away. Nope. Listen, from Raytheon, unlike the RIM 7 Sea Sparrow missile and ESSM Block 1, Block 2's active seeker will support terminal engagement without the launch ship's target illumination radars. That means the Block 1 must have the target illumination radars on the ship. Does everyone understand that? The evolved Sea Sparrow, see, the Block 2 is not a problem. The Block 2 is not a problem. Why? Because the Block 2 is not going to be ready until 2020 with 80 missiles going to the fleet. So the problem is for them, the Sea Sparrow Block 1 has been in full operational use since when? 2004, right? Therefore, please tell me how the ESSM Block 1 has been engaging surface-based targets at more than 35 miles with the target illumination radars on ships for the past 14 years. It's over right there, folks. The spinning ball religion is dead. The end. Oh, another one of my favorites. Of course, all these four are all my favorites. In fact, I had these four arguments 3 days after I realized that the Earth was flat and all this was buffoonery. These four arguments, I may have tweaked them just a tad, but they're the same ones. So the Earth is not spinning. And here's a big one, too. Most people don't know what the Coriolis effect is, right? I think the latest one I got was toilet water spinning. I mean, this cracks me up. I can go into my bathroom, my sink and my toilet, same room, 3 feet apart from each other. My sink spins from left to right, facing the same direction. My toilet spins from right to left. Are they separated by an equator or something? See, it's ridiculous stuff like this. But let's get into it. Let's get to what is the Coriolis effect. For the Coriolis effect to exist, you must have, that is, the necessary condition, 2 differing frames of reference, 1 rotating coordinate system or non-inertial, the Earth, and 1 non-rotating coordinate system, inertial, the atmosphere, and everything in it. So from Seagar, Douglas, Introduction to Ocean Sciences. This is college level textbook, folks. So the Coriolis effect. When set in motion, freely moving objects, including air and water masses, move in straight paths while the Earth continues to what? Rotate independently. Because freely moving objects are not carried with the Earth as it rotates, they are subject to an apparent deflection. Very important point right there. Apparent deflection, called the Coriolis effect. To an observer rotating with the Earth, freely moving objects that travel in straight paths or straight lines appear to travel in curved paths on the Earth. Let's take a look at this. Let's go to the Elmer Fudd wiki. This is good. This shows you exactly what this definition just said. It's a illustration of the exact definition. So the little red dot, let's look at the top one here. The little red dot is anything attached to the Earth rotating with the Earth, right? It's like a merry-go-round. You're spinning this way. However, if somebody throws a ball that's not attached to the merry-go-round, it goes straight while you turn. But it appears to you, take a look at the bottom illustration, it appears to you that it's curving. Well, that curving is just an appearance. That ball's going straight. That's why the Coriolis effect is an apparent deflection. It's not real. So, what's rotating? According to this definition above, what's rotating? Well, the Earth's rotating. What's moving in straight paths while the Earth is rotating independently? Well, air and cloud, the atmosphere, and everything or every freely moving object in it. That's bullets, planes, balloons, anything that's not attached to the Earth. Wow. If the Coriolis effect is true, and it is, you could do it on a merry-go-round with the ball I just showed you, then its necessary conditions, A and B, that afford its existence are therefore true, right? So the Earth's rotating and the atmosphere and everything in it's not. That must be true for the Coriolis effect to exist. And it does exist. So if A and B, then a flight from North Carolina to Los Angeles nonstop, traveling at 500 miles per hour airspeed with both locations roughly the 35th degree north latitude, that is, they're both allegedly spinning at 860 miles an hour, should be approximately 1.5 hours. But it's 4.5 hours. The Charlotte to Los Angeles flight, airspeed's 500 miles an hour. You have to take the ground speed and the alleged rotation speed that's coming in your face and add them together. So that's 1,360 miles an hour. Just do the simple math. In other words, based on the law of non-contradiction, each, the Coriolis effect, and this is important, with respect to the Earth and the Charlotte flight at 1.5 hours are either both true or both false. So the flight is most assuredly false. Therefore, the Earth is not spinning. The ball goes by way of the dodo bird, or you're a stationary ball geocentrist. It's just that simple, folks. This cannot be refuted. These proofs cannot be refuted. If I went through it too fast, don't worry. Go back and go ahead and review it. You'll find it's irrefutable. Along with this one. There is no vacuum of space, folks. Number one, how do you have a gas pressure, that is atmospheric pressure, air pressure, without a container to begin with? When the pressure of a gas is the force that the gas exerts on the walls of its container. This is the definition. How can you have gas pressure without this, right? And we all know this by, just general experience. An incoherent third grader knows this. But I get fights to the death over it. The main comeback with this is, well, we have different pressure gradients. Well, who cares? You're starting off with a pressure gradient. Where'd you get gas pressure first? You have to answer that question first. So, I don't know. I can't wait to hear this yarn. You can't have gas pressure in an open system. And according to the fairy tale, this is the Earth is an open system. Married bachelors are more tenable. So basically, please explain how you can have a tire pressure without the tire. Right? It's preposterous. It's lunacy. Number two, how can you have a vacuum outer space attached to a non-vacuum Earth without a physical barrier in the same system simultaneously without bludgeoning to a bloody pulp the laws of entropy or the second law of thermodynamics. You can't do it. In other words, how are you still breathing and adhering to your fairy tale religion both at the same time? Then you need to define the law of non-contradiction. Then list each fairy tale associated with outer space that gets taken out back to the woodshed and bludgeoned senseless as a result of the fairy tale vacuum of space vaporizing. And this is kind of fun. How in the world did the Earth form an atmosphere in a vacuum from a Big Bang? You're not forming a vacuum. No way. Have you heard that nature abhors a vacuum by chance? Why is that? P.S. from Arthur Eddington, Nature of the Physical World in 1930. If your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for your theory but to collapse in the deepest humiliation. The end. You live in a deeply humiliated fairy tale. Thanks for your ear. Have a nice day.
Awesome, John. Absolutely love it. Made a few changes from when you presented it the first time.
Yeah, it was kind of long, and it still is long. I changed it. I wanted to put the big guys in there, refraction and gravity. I could have went down a number of different paths. There's like 800 different types of arguments, but I figured I'd just go for the big ones.
Initially, when you were approached, I can't remember who approached to you or I, but either way, you kind of assumed that we would be devastated about losing the idea of presenting things in models. What gave you that impression?
Right. Well, like I said, everyone uses the term science, models, and predictions. It's not this sword cuts both ways, and I didn't want to come across as, hey, look at this jerk. He's ruining everyone's arguments. But hey, listen, we're in for the truth, and models aren't science. Science terms have definite meanings in science. They mean things. If you say experiment, well, that means certain things. Certain necessary facts have to come with them. You have to have an independent, dependent variable with an experiment. You just can't say, well, I'm conducting an experiment, and it's just a visual type of thing, right? It has to be something. Models, they have definite definitions. Same thing with all the rest of the terms. And people just flippantly use them. And they're out of context. They're meaningless. In fact, they mean the opposite. So there's a lot of confusion out there. I just wanted to put most of these things to rest. I doubt that I will, because I've been preaching this stuff for over 2 years now. It's not making any difference. But, if somebody's just coming into this and they're new, maybe this will give them a leg up.
I truly hope so. I mean, I've watched all of your shows on Cathexis channel, and I've put a link to the Gravity one in the description below. I'll make sure it's on the re-upload as well. So click on that and check out. I'm sure, like me, you'll get hooked. But it takes a while for some of these concepts to sink in. You're right. I have heard some of the things a few times before, but that doesn't mean I've understood them. And it's taken, a few conversations to date for some of these concepts to sink in fully. One of the things that I asked the rest of the QED team to do was, scribble away some questions maybe so we could have a chat afterwards. So we've been joined by Sleeping Warrior. How are you doing, Sleeping Warrior? Good to have you.
All is good. I've just got a couple of quick questions, hopefully straightforward questions, but undoubtedly they'll be not as straightforward in answering. But when you were talking about fallacies before, some of the fallacies have got more weight than other fallacies. For example, the straw man fallacy. If somebody introduces a straw man fallacy, when challenged, then you address the straw man fallacy that's been introduced and either accept that it's a straw man fallacy and dismiss it, or justify why it's not a straw man fallacy, and then you move on from that point. So the introduction of a fallacy deals with the particular distraction in hand. How do you deal with a fallacy where the guy's cornered and then he introduces a fallacy as a means of distraction away from the fact that he's cornered, and you're really moving in for the kill, and you want him to admit that he's wrong, but he's using a fallacy to get out of something, and usually it's a fallacy that I've either not heard of or is like non sequitur, in that it doesn't even apply, but it's used simply to distract from the fact that he's cornered. How do you deal with these fallacies that are used, basically introduced as a straw man fallacy in itself? You know, like they're not introducing a straw man fallacy, but they're introducing a straw man fallacy to avoid defeat. How do we deal with these? Because this happens quite frequently. They don't want to address the point. They want to create a fallacy that wasn't there in the first place, kind of like a straw man, but rather than admit defeat. How do we best deal with this particular distraction technique? It's a form of fallacy in some way, I'm sure.
Yeah, well, the way I deal with any of the fallacies, I mean, there's a number of them, but there's common ones that people use. I just identify them, and then first you have to define it, right? So a straw man fallacy, or a red herring fallacy, or a begging the question fallacy, I just define it and then hold their feet to the fire with it. That's really all I can do. I'm not chasing fallacies. When somebody introduces a fallacy, like a begging the question fallacy argument, like refraction, I just stop it right there. I'm not chasing that thing down. I'm not answering it. It's a fool's errand, in my opinion. I identify them and move on.
Yeah, I mean, me and Nathan have had this discussion loads of times about 7.6R. It's based on the radius of the Earth, right? And it's an assumed radius of the Earth, and Mick West himself admits and accepts that it's an assumed radius, and yet it's cited anyway. And it kind of goes two ways, because if you stop it where it starts, then there's no debate on it. But they don't want that to be the case. They want the debate, and I'm quite pro-debate. I like the idea of arguing and discussing it. So I tend to like give it them for the sake of discussion. And it's like, ultimately, it's like, should we be giving it because of discussion, or should we literally stop them before unless they can prove there's a radius for it to be based on, right? It shouldn't even be a discussion, right?
Yeah, in my opinion, yeah, I'm not chasing fallacies down. I'm not giving it to them. I guess it's, personal to everyone, but I mean, if I'm in a discussion with somebody and they're trying to provide evidence, and their evidence is based and is fallacious, well, that's just wasting my time.
Yeah, I agree. But I think sometimes the opposition tends not. Well, they will accept that a radius exists, and they will accept that it's on us to prove that a radius doesn't, because they'll flip the burden of proof. Yeah, he who asserts must prove, and evidence assertions made without evidence can be dismissed without evidence. They're the two fundamental principles on discussion. But if they all accept and believe that a radius exists, they won't accept that it's a fallacy in the first place, right?
Well, it doesn't matter whether they accept it or not. Is it a fallacy or isn't it? Everyone has the opportunity to say nuh-uh, but they have, and that's a claim. If you say nuh-uh, then provide support why it's a nuh-uh. Right? Yeah, I'm not chasing fallacies, man. I'm just not doing it.
They beg the question continually, and it gets to the point where, with non-standard refraction, you're into the point where you're presenting your audience with a flat plane observation, plain and simple, and it's been, obfuscated to the point of absurdity. You're saying there's a curve where there is no curve in the most literal of senses, and it is frustrating.
So essentially, we should stick to our guns and say, right, instead of conceding it for the sake of the discussion, prove that there's a radius, and then you can have refraction, right?
That's right.
But exactly. The problem with that is that there is then no debate or discussion, right?
Well,
so
sorry, I gotta.
Sorry, just got to interrupt. Malobservation.
It's not refraction. Sorry, Anthony, I've just got to get this in there. So it's terrestrial refraction. So when you say prove the curve and you can have refraction, well, refraction does exist, but it's this assumed terrestrial refraction that bends light around an assumed curve of the Earth that we don't want to give them because it assumes there's a curve. In other words, it begs the question.
Yeah, but the problem with that is if we don't give them the refraction around a curve, then the Isle of Man debate would have been one show, because a lot of that conversation and disagreement was based on what we think we're looking at and how much of it should be obscured. But obviously, if the application of 7.6R isn't to be credited on the basis that there's no evidence of a radius, then if they're begging the question, then Nathan doesn't really have a show, right?
Yeah.
I would agree, but people still do. And it's nice to point it out and hold their toes to the fire. You know, that's part of the show also. I mean, I'm happy for people to concede whatever belief they like, so long as they concede that it's a belief. And if they don't understand or don't recognise that, then that is also part of the show. Also, neither you or I hope you'll agree, were appreciated that it was begging the question until we went through the journey. You know, when you actually realise the evidence of your own eyes, what you see is what you get. It is a flat plane in photography that you're presenting, and that's always going to be the case. But once you have this 7.6R and then further pushed to non-standard refraction, you know, it is a logical fallacy. And you have to appreciate that by going through that baptism of fire and having them argue that with you before you'll recognise it. So it passes itself off for a lot of debates or debaters, whatever you want to look at it, whichever angle you want to look at it from. They get obfuscated by that fallacy. And we have gone through that. And it's nice to draw a conclusion at the end of it and say we will not accept by default that there is a curve and that light is bending around it.
Yeah. And we also won't accept by default that there is a fallacy just because somebody may well be cornered. For example, Paul Voigt. Paul Voigt's claim, or the claim by science, is that we live on around Earth, or a spherical Earth, and inside the spherical Earth there is a molten solid iron core that convects its current and its heat to create movement and inertia, which in itself creates its own electricity, which is where we get our gravity and magnetic effects from. Yet no evidence exists for this. And Paul I'm sure he was trolling me today, but Paul was trying to argue that if it's accepted by science to be fact, then the burden of proof lies with you to challenge and question the fact that's accepted by science. And I was like, what are you talking about? He who asserts must prove. Assertions without evidence can be dismissed without evidence. That's the fundamental principle of arguing in science. If there is a hypothesis or an evidence or an experiment, the results of that experiment are subject to peer review. And that whole basis is science. So to try and flip the burden of proof against the one that's challenging the science is a fallacy in itself. I just don't know what the fallacy is other than it's lies. So if you're going to make the assertion, i.e. we live on a ball with a molten core, the evidence to prove that falls with the one that holds the assertion, in this case, Paul Voigt. To flip the evidential burden against me for challenging it is something fallacy, but I don't know what fallacy it is. Is it just simply dishonest? Is it a misunderstanding of science? Is it a misunderstanding of evidence? Or is it some other form of fallacy that needs to be named? Because the burden does lie with science. If it claims to have a molten iron core, guess what? We want to see that evidence, please. It doesn't exist. So Paul has to flip the burden against me because he knows that he can't prove it. And I don't know how best to deal with it other than calling him a moron, but I don't want to call him a moron. I want to try and articulate it in a way that puts him back in his hole. How do you deal with somebody that won't accept that the evidence is required by his assertion?
Well, we already went over this in the presentation. Number one, you said the claim by science. Science doesn't make claims, man.
Well, somebody's made the claim that we have a molten iron core, and it's accepted by everybody.
Appeal to authority.
Can make the claim that invisible fire-breathing dragons exist, right?
Yeah, it's science by consensus and appeals to authority that you have in that particular instance. I'm sure you probably got, maybe or maybe not, you saw the debate we did on Steve's channel, and you've gone to, on several occasions, again, plug Cathexis's channel, check out Science versus Scientism series, the 14 episodes that John did, because he's gone through some of the tactics that they use when applying science by consensus, which is what they did when we went on there.
Flipping the bird fallacy. That sounds like a reasonable one.
See, it's this one. They're giving you an explanation. Number one, like I said, science doesn't claim anything because it's not an entity. It doesn't have any vocal cords. It's not doing it. And what he's doing here is, well, has anyone been to the core of the Earth?
No.
Has anyone? Do you have a viable independent and dependent variable? No. You don't have an experiment. You don't have science.
Yeah,
So,
they have the seismograph argument, don't they? The seismology argument.
The seismology. They don't. That's not science. Those are just so stories.
True.
That's what it is. It's an argument from complete ignorance. It's just like my invisible fire-breathing dragons.
So how do I get Paul to realize that the burden of the evidential burden actually does lay with him, or is he trolling me because he knows this?
Well, yeah, I try not to convince people. I usually, because that's too hard. You can't control that, and most people just look you dead in the face with evidence staring right in front of them and just deny it.
Yeah.
Well, that's okay. I'll just expose you that if anyone comes along and looks at this, you're finished.
We have had to use the phrase "you're just a denier." On several occasions, people will literally dismiss the evidence that they're presented with, and me and Nathan have said, "So you're a denier." And me, ultimately, if that's the way it has to be, then it kind of takes it personal. But if it has to get to that point, then I guess the conversation is lost by us because we have to take it personal, like make it into a personal, because people will just literally deny the evidence that's presented under their nose because science. Like even Paul Voigt said that he will always apply non-standard refraction no matter what, because we live on a ball. That is literally his words. He will always do it. And
well, he can do that. That's fine. That's a begging the question fallacy, and I'll move on to the next one.
Yeah, people are entitled to their beliefs. If they want to believe that, then that's fine.
Look, you made a good point there before, Nathan, with beliefs. There's a difference between a belief proposition and a knowledge claim. A lot of people confuse those two things, right? You can believe whatever you want. That's fine. You're good to go. I don't really care. But if you're making a claim, you either have to validate it scientifically, which in this genre you can't. Because of the reasons I went over before.
I've been accused of falling into solipsism, though.
Argument.
Would you agree? You know, people have accused me of falling into solipsism.
You broke up there, Nathan. Go ahead again.
I've been accused of being falling into solipsism. I mean,
why is that?
Well, requiring it for my own satisfaction. You know, being able to physically lay hands on things.
I don't think that's solipsism. Solipsism states that more or less only you exist and everything else is a fairy tale. So I think they're using that term out of context too. That's not surprising.
Yeah, but they have to use the solipsism argument to explain stuff that they haven't got evidence for. So that's the counter to being pseudoscience, right? You're going to be you're going to succumb to solipsism because you don't accept everything that you don't smell yourself. Well, unless you can prove that it's got some evidence to support it, then it has to be dismissed without evidence, right? Because you've not got evidence yourself. That's not solipsism. That's just literally pointing out
lack of
evidence. Haven't got evidence.
Right.
That's not solipsism.
That's right. It's a lack of evidence. So, like I said, it either has to be scientifically validated. That's the preferred, but not everything fits into the scientific method. Only cause and effect questions can fit into the scientific method. That's the only thing that can fit. If it can't fit in there, it's not science.
There was one.
What is it? It's not science. Pseudoscience.
Well, I was just going to ask a word. Pseudo something. It was like pseudo-Romanian. There was a word in there I didn't know.
Pseudo-Romanian force. Yeah, force space. Yep. Pseudo-Romanian. It's a false. It's pseudo just means false. It's not real. It's the opposite of what it is. So pseudoscience is more or less pretending that you're one thing, but you're actually not.
No, but you had pseudo-Romanian or something, I think it was the word.
Yeah, pseudo-Romanian force space. They treat time as a dimension.
Okay.
That's why it's called pseudo.
Gotcha.
Because time doesn't have dimensions.
No, gotcha. You explained that before. I just didn't put the two together. So yeah, that makes sense now.
Yep.
Cool. Did you have any other questions, Anthony?
I think Arwin wants to come in. If Arwin's out there listening, he's messaging Skype asking, can he join? I've told him he can, but I don't think he's seen it. So if Arwen's out there, join.
Give him a couple of minutes. I'll send him the link, and if he doesn't,
I think Chris was on about joining as well. I think he wanted to mention something, but he's not responded in Skype, so I'm not sure if he's seen it or if he's in the shower or something. And there will be other things that I want to ask if other people do join in, because it usually creates a tangent that ends up being somewhere.
I don't know how long John's got. So how long have you got to spare, John?
I could stick for another 20 minutes or so.
Well, if Arwen joins, you'll definitely be needing them.
And why is that?
Arwen's got a lot of questions.
Well, hopefully I have some answers.
He believes in fire-breathing dragons.
He does not. That's not so.
I'm joking. He probably doesn't. He might do. No, I don't think he does.
Yeah.
Okay, well, I've sent Arwen the link, so you may or may not join. If not, we'll round out shortly.
All right, here's a question for you. Elon Musk recently said, quote, you can tell it's real because it looks so fake, unquote. Do you take that as an admission, or do you take that as like is he rubbing their noses in is he rubbing their noses in it because he knows it's fake? I take it as an admission myself. Some people see it as rubbing salt in the wound.
Idea.
Yo.
No, I have no idea either. The guest earlier today on the debate show said, it depends on your perspective, and he's not a mind reader, and
I see it as an admission myself.
I'm not a mind reader. I can't get into his mind and what he's trying to do. I thought it was a ridiculous statement.
Yeah.
Yeah, it was a ridiculous statement. That much I'll agree with too. How you doing, Arwen? Did you have a couple of questions for John?
No, I'm now regretting feeding the trolls in chat for the last 15 minutes.
If there's no other questions, I might round out the show. But I mean, you're welcome to interject in any way you feel necessary.
It's just
Arwen.
the thing that I really hate these people. I really, really do. And this roots back way to my early youth when I had the same type of people just surrounding me and constantly bothering me. And I have this weird tactic that I think that if I don't respond, then things turn out fine. But then sometimes I just can't help it. And then I try to just overfeed them. So they'll just explode. But it doesn't seem to work.
Well, I've certainly seen John embark on some epic comment threads, shall we say, in the YouTube videos that I've seen you commenting in, and I don't know how you do it because you're pretty tenacious when it comes to the comments.
I do my best. Yeah, it's like once I latch on, then it's very hard for me to let go because I don't want to let go until I'm pretty sure that there's just no way out for them. So they have to commit spiritual suicide, basically. Because
John chatted with one of our favourite guests on the debates, which is son of an astronaut, M. Scott Veach. Do you remember that comment thread, John?
Yeah, I recall it. I'm not going to talk about anyone here. They can always go to the threads and go ahead and look them up. I try to stay away from the 8th grade slumber party type of stuff. That it turns me off. I'm not into that,
Fair enough.
Pillow fight.
Pillow
fight stuff. They start calling others names. Listen, I don't have a problem with anybody. If you got a claim, then just go ahead and support it. I have no problem. If you can't support your claim, then it's a fairy tale. Just reduce if you can't support it, don't tell me what other people told you. Don't tell me what these pseudoscientists, these guys. Is my screen still up?
Yeah, it is, yeah.
Mm-hmm.
Yeah. See, don't parrot what these guys tell me. I don't want to hear it. Because
but the problem is that you seem to be a very reasonable person, and by the way, I really, really did like this presentation. It was awesome.
Well,
you really got to the details with a great presentation with text. I loved it. But the problem is with these globers and these trolls and this really is it, they don't want to learn. They really, really, really don't.
Well, it's not
And
for
that's the
them.
problem, is that they have tactics to evade whatever you present to them forever.
Oh no, they don't.
No, they do. They really do. They will go literally beyond death into hell. Into hell forever to avoid that truth, to avoid giving up on their religion, because they
Well,
just can't. They can't let it go.
well, the presentation wasn't. Then it's not for them. It's for
Yeah, but
other
of
people.
course it's not for them. It's for people that actually have a mind and critical thought processes. But they will always be the ones that actually latch on and then try to get as much in the way as they can, because they can't help it. But yeah, the presentation was great.
Well,
Loved
thank
it.
you. I appreciate that.
Yeah, it's really good to get back to the details of the scientific method and what it really is, and
So
Right.
just before we introduce
dispel
Chris,
some more illusions.
just before we introduce Chris, can I just get you to repeat what you just said? If you can't back up your assertions, it's a fairy tale, right?
Yes.
I agree. So the Curie temperature and molten iron and all that is a fairy tale unless you can prove that it's true.
Exactly. And we have the opposite of that. Like I said, I took that out of the presentation. It was too long. I took it out of the presentation, but you can go find that information. Just find, the Curie points of iron. It's supposed to be what they tell you is that the core of the Earth is an iron nickel mixture. Well, just go find the Curie points of those characters, and it's over.
Yeah,
It's simple.
for some reason, Paul thinks that there's a lack of evidence to show that iron and nickel can't self-perpetuate. And I'm like, the Curie temperature, the Curie point of it shows it. Come on,
Yeah.
Paul, wake up. I'm sure he knows this, but I'm sure he's literally trolling. But I'm not sure. I'm not sure if he actually believes it as well, though.
Yeah, that point's over in like 45 seconds.
Yeah.
Well, they're trolling and they believe it at the same time.
That's why I can't tell. Is he deluded or is he just pushing the narrative?
Both. It's both. It's simultaneous,
Yeah.
because they know both work together hand in hand. It's a deal with the devil they made with themselves.
They've been joined
So-
by Chris Monk.
Full
How you
of
doing,
facts.
Chris? Just a quick introduction. How you doing? He'll come off mute.
Chris?
Earth to Chris.
He did come off mute for a second. He's at his desk. Hello.
Am I there? Can you hear me?
Yes,
Yeah.
we can. Good to have you.
All right, yeah. Thanks. I only had just one quick question. If we just to take a step back, once we've accepted the truth that, it's a flat plane realm and all that, and we rejected the globe entirely and heliocentrism and all that comes with it on the pseudo-scientific basis and the fallacies, what do you think would be the next step going forward as far as developing basically a flat-based real science based on natural law and theory and go forward with, something that works, right?
Well, yeah, it all depends on how much resources we have. There are still things to figure out about the flat Earth, in the sense that what is really the shape? Is it a disc or is it a looping rectangle? That type of thing. And there are experiments ready to be executed, they're ready to be done to figure this out. But yeah, it will require some travel and some measurements and some cooperation.
Now, let me ask you this question. I just went over what the scientific method is. We talked about experiments. We talked about hypotheses. You will not be able to formulate a hypothesis or an experiment to validate the flat Earth. Can't do it. It's a different question. Remember, we're talking cause and effect questions in the scientific method. The question whether the Earth is flat or whether it's a sphere is outside the scientific method. The only way you can get there is logical consistency arguments.
Yes, well, if it were to be a globe, then they're of a specific size, at least. which is assumed currently in the scientism community, then the exact curvature would be very specific. And you could then test if that curvature would actually be like that. And so far, we have no proof that it is so.
But that's not an experiment, though. That's not a scientific experiment. You can't, it's not.
Is it not? Is not just checking the optics to see if it is consistent with that model?
That's the only thing it is, right? You got to see if it's logically consistent. Yes. Yeah, that's all you got. Now, I'm not saying that that's wrong. I'm not saying that. All I'm saying is that's not scientific evidence. Follow me?
All right.
That's all I'm saying. I'm not putting. There's different methods to get at truth. One method is the scientific method, but that only adjudicates cause and effect questions.
But isn't working out how optics actually work, and then having that knowledge of just how optics work, like how does optics respond in certain types of atmosphere, in certain distances with certain lenses and cameras, and then if you have that knowledge through this gathering of all these types of observations, can't you then use the formulas for that knowledge to basically figure out once and for all what the consistent shape of the Earth is? Is that not a scientific proof?
No, it's not. But it's not part of the scientific method.
I was thinking more along the lines too of not so much the shape. I mean, it doesn't concern me all that much really. It's the outcome of the basic root of the science itself, right? To redevelop science that actually works on the fundamental laws, and come up with a new scientific methods that can go forward with new technologies based on the rejection of the fallacies contained within the globe and the heliocentric models, gravity and all that stuff. Right? To discard that and come up with a basis, some sort of a really base way of going forward with a new science, like completely new science, not going back to, alchemy, but coming forward. Like there's got to be a line in the sand that we can draw and move forward with something that's new that works for everybody. Right? That's kind of what I'm thinking. How would we go about such a thing? Right. Development of basic fundamental experiments that can prove new things. Right. Dielectric models and different not models. I don't want to use the term model, but something that's we accept to this first define whether or not it's an open or a closed system. Obviously, whether it's you've debunked the vacuum stuff that makes absolutely no sense. Get right back to the basic fundamentals of entropic states. Right? Do we have to redefine some of the basic laws of thermodynamics to make them work within it? Without assuming.
The laws of thermodynamics are fine. It's just the pseudoscience parroters that don't know what they mean.
Yeah, exactly.
Yeah, and remember I said, and this is really important, I think I went through a presentation on Cathex's channel for this one thing too. And a lot of people, they arch their back when I say it. And I think I went over it here just, briefly, was that, scientific laws, when somebody says scientific laws, that's an oxymoron. It's a misnomer. Because the laws aren't scientific. They don't enter the scientific method. They are only descriptions of natural laws. That's all they are. And that breeds a lot of confusion when I say that to people. They're like, what? But if you sit down and think about it and see what the scientific method is, like I said, with the second law of thermodynamics, you can never find out a cause and effect relationship with it. The second law is only a description, right, of what happens, entropy, correct?
Correct,
Heat always flows from hot to cold, always, from high concentration to low concentration, always. Well, what's the cause of that? Well, we will never know.
Well,
It's hard. The question
expansion distribution, it's just a natural effect.
Mm-hmm.
It seems to be part of the pattern
Yeah.
to balance out things.
Yeah, it just happens, but you can't isolate a cause of that. The question's even a name, right?
Well, it just seems to be a certain pattern in
That's right.
in all things to balance out, to find the balance.
Well, that's why it's a law
Equalize.
and not a scientific theory. See, scientific theories result from validated hypotheses, right? They come out of the scientific method. Scientific theories answer the how and why and the cause questions. But when someone says scientific laws, and I do it myself because it's inbred in us, from the beginning, but it's wrong. It's wrong to state that. It's out of context. You guys following me with that?
Yeah, sort of. It's just you're making it even harder than it already was. Thanks.
Well, that's kind of what I'm thinking, right? Is to come up with some things that really define the you got to have the boundaries defined. If you're going to try and work within a system, you need to know the boundaries, right? And that's my problem with some of these modern scientific approaches is that, well, you end up going, to infinity in one direction and to absolute zero in the other in the other direction. Both cancel each other out, and you end up with nothing being definable. And the what did you call it? The solipsism argument. You can't prove nothing, right? So I'm trying to avoid that. Right? But still come up with a way to move forward, right?
Universal problem in modern science is that so many things are based on pure theoretical assumption, and those theoretical assumptions are just grafted into the whole thing as if they are physical reality.
See, and that's another problem. To uphold
a certain image, and it seems to be a big problem. It's almost like they refuse to migrate the border of the actual physical sciences and instead encourage the theoretical sciences to migrate and to bring in more theoretical science as physical science.
Yeah, but there is no theoretical science. That's where the problem lies.
Yeah. Well, science as in an occupation, as in theorizing, and but that scientific method. I know what you mean, but the thing is that, like math science,
just
you're getting me on semantics, you bastard.
I always wonder what evidence is there. If we start right at the basis of point zero and say what evidence do we have to determine whether it's an open or closed system. Start with that one question: is it open or closed? And then kind of go from there. Like, what experiments could we do to determine a very simple question like that? Is it open?
Well, we already know it has to be closed, right? Because you can't have gas pressure in an open system. It's impossible.
So it has to be closed. Well, definitely be locally closed.
Yep.
So what's the boundaries of what's the boundaries of that system? And that's where we have to start, right?
Yeah, that's a good question. The locally it has to be closed. Exactly right. Now, can you get outside of that? No.
Nope.
So everything's conjecture at that point.
Yep. In an infinite space, there can basically be zero pressure because it's always going to try to divide itself among the infinity of the vacuum out there. So it's just never going to, pressure can only be in a contained system.
Yeah, but infinity doesn't exist in reality or mathematically. So this infinity
is like the same concept of that of time, right? That's a conceptual idea. So I'm trying to get to very basic roots of, like we said, if we have evidence that it's a closed system, which it appears to be, right? Then what can we do with that very fundamental information?
I'm sorry, Chris.
What the dimensions are, how the enclosure actually works. Is there
Excuse
a
me, guys.
dome surrounding it, like a bubble, or is it a spatially confined system, like a grid of looping
Is,
space?
is Nathan still there?
Yeah, sure. I'm listening. I'm totally
Oh,
engrossed because I want to hear you guys thrash these things out.
are we off air?
No, we're still on air. If you want
Oh, I
me
thought
to,
we
I'll
were
round
off.
out. I intended this to be about an hour and a half, and we're a little bit over that now. But I'm engrossed in the conversation, hence I've not said much.
Okay. Sorry about that. I didn't mean to interrupt you guys. Go ahead.
Well, to me, it definitely seems that there's a boundary above, for sure. As far as we can tell, we can only determine things to within certain limits of resolution and observation, whether it be by eye or telescope or any other means, radio. It doesn't matter. And obviously, there's a boundary below that, for all intents and purposes, appears not to be based on hot iron, Curie temperature limits that don't exist, right? So it has to be something else. It does have charge and density, obviously, and momentum in a linear sense of orientation, bias to the positive in a Z direction. So those are kind of the boundaries I set in my head, and then try to figure out what does that result in, right? Where do we go from here with a new science, right? How do you use that information without becoming nihilistic and obviously divulging things or whatever that might be dangerous to the survival of the species,
Well,
There's some pretty powerful stuff in that when you start thinking about it, right?
I've been considering that if if even some dimensions of this world would be confined by a loop, then it almost seems illogical that only certain dimensional directions would be confined and not just all of them. And then I figured out that if there is a confinement dimensionally upwards, if there's a ceiling, then either there seems to be like a step case of potentially infinite worlds or some kind of weird infinity up there, or we could basically be looking at the bottom of our Earth.
It's interesting. It's an interesting idea, because I know the quantum guys, and maybe John can speak to this. The quantum guys I know right now are grasping at straws, searching for quantum gravity with orientated up and down quarks, right, which gives us up and down because they know full well that gravity, so-called, relative to mass, does not act in a horizontal plane like left and right. It's only up and down. It doesn't act. Mass does not attract in a linear sense, left and right or horizontal, right? When you suspend things from large masses and small masses near each other in a vacuum, and they don't attract sideways. The Cavendish experiment is bunk, right? So we know that. So I'm wondering, I know John's into the quantum stuff, so what do you think of the up and down quarks and this quantum gravity search, right? Because they're still grasping at straws to prove their so-called model, to use it in their terms, right?
Right. The quantum gravity, it'll never be found because, number one, gravity doesn't exist. And quantum mechanics and gravity, it's like married bachelors. I mean, it's not going to be resolved. It's already resolved because there isn't any define gravity. That's where the problem lies. I mean,
well, exactly. The definition itself is flawed, right? I mean, when you look up the definition of gravity, it doesn't work. It's undefined, right?
Exactly. You got it. That's right. That's exactly right.
But certainly velocity and directional bias does exist.
Sure.
Up and down is up and down. And that, to me, that implies velocity at a quantum level, right? Spin axis. Yep. There seems to be a spin axis in quantum particles that is up and down, like electrons. The nucleus is biased. There is a north and south, so to speak, in electrical terms.
Yep.
Right. The magnetic field is right. The right hand rule is everywhere, and you'll never get out of it. Right.
Right. Exactly. Yep. That's experimentally validated. Correct.
Right. So I'm wondering, what as people that are rejecting the globe system because it fails scientifically, then where would we start to move forward as a group? And should we look at starting up some kind of a foundation or a library of? I know FE Core is trying to do some of that type of work, independently, but it's difficult, right?
Right. Sure. Well, you wouldn't have to recreate the wheel. I mean, You could start off at the basic principles, the experimentally validated principles. I mean, there's a ton of them, and then go from there. You just have to drop all the nonsensical baggage that comes along with those experiments. You know, the stories. That's where it is. A lot of the legwork's already been done. It just depends on the question.
Yeah. Like when I look at the work of who's a good example, maybe Stephen Kevelson from I'm not sure which university he's with. He's a condensed matter physicist, and he's done a lot of work with superfluids, heliums, and superconductors, and the ring conductors, and that, and the Josephson junction.
Right? Oh, the Josephson, yeah, that's outstanding stuff right there, man.
There's some stuff in there that will really make you second guess everything you know about reality itself, right? And it's right. So, for here's how I see it. For years and years and years, 50 years or 100 years, we've been going down this path of vacuum space and spinning balls, infinite exploding Big Bang theories that are expanding forever, time dilation theories, and all this other crazy stuff, right? But then when you just take a moment and look at this condensed matter side of it, like the inward implosion, cooling to as close as we can get to zero, and as soon as you cross that phase transition point, you're into superconductivity.
Yep.
And there's some amazing stuff to be found in
there. Is.
Right?
Yep.
Right. So.
Yep, and that has all of its foundations in quantum mechanics. Yeah. I really like looking into that stuff. I ran across Josephson junctions about 8 years ago, and I was studying it for about a couple months now. The ramifications of that is mind-boggling. Just absolutely mind-boggling. But hey, and it works. It's experimentally validated. So there's not too much you can say about it. People can deny it all they want. But yeah, it's truly amazing. Quantum mechanics really settles. Like I said, it depends on the question that you're asking. Right?
Right.
Exactly right. Yeah.
I think on that note,
I've often thought I don't know. Okay, carry on, Nathan. Go ahead.
No, you go ahead.
Oh, just in this train of thought. I mean, I've often thought if we were in a closed system, obviously, and essentially what we see as matter and physics in our reality is, call it 0.0 on the scale, right? So, however, our 0.0, what we think of as reality and matter, is indeed a superconductor in and of itself. And it's only when we go, and because we've become equalized in this superconductive state, and we try to move towards the zero of absolute zero coldness, there seems to be a limit where we can start to overcome that into that superconductor, a cold state of matter, right? So I don't know whether it's a way to approach things on the assumption that we're already in a superconductive state. And things like magnets are just conductors of the field that we're in. Right? We're balanced in a neutral state, and our understanding of magnetism, magnets are just conducting this field that is already there. Right?
But in a sense, like if you think the South Pole circle type of thing, then all of that out there would be extremely cold. So that could be even part of creating the magnetic field, just the coldness out there. You ever consider that?
Oh, absolutely. Like if we this is obviously theoretical and hypothetical, but if we took the state of the allegory of a superconducting helium fluid type of experiment, and for example, where we exist, we're inside of a bubble within this chamber and surrounded by super cold fluid. Yeah. And obviously we would be rejecting all magnetic fields except for the field that we're containing, because that's what superconductors do, right? The magnetic field goes around in the ring for as long as the universe exists, right? And it's stable, right? So I think there's possibilities that is exactly what we're experiencing.
Huh. That's right. Really interesting. That really never crossed my mind before.
So you're right, in that sense, you can't get out of it, but it also protects you, that which gives us pressure in life. It does both at the same time, right? Ain't no getting out, and and I'm sure glad it's there, whatever it is, right?
Well, it certainly makes the concept of global warming a lot scarier. Like,
Right.
if that could even be possible, that any type of temperature change within the world could actually affect that. I doubt it personally. But then, yeah, if something would cause that super cold that would induce that magnetism to go down, then that could potentially catastrophically destabilize the entire system. But yeah, I doubt that some gases out there could actually do that.
So on a slightly different note, I was, as I say, I was hoping to round out maybe 5 or 10 minutes ago, so I'm going to ask John if there was any last points that he wanted to get in before I do round out, and thank you all for being here.
No, that's all I have, Nathan. Thank you very much for allowing me to present, man.
No, it's been
Likewise, a very, very great presentation, John. Nice for
It's awesome.
having a couple of questions there. Excellent.
Yeah, it
Thank you.
It was a damn good presentation. And with that, I will say a massive thank you to Arwin, Sleeping Warrior, and Quantum Eraser for joining me on this Science versus Scientism episode. Be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I will see you all in the next video.